Okay, so for our double angle formulae so far, we said that what we're going to do is we're going to apply it to this problem here. Simplify 2 sine 15 cos 15. We began the conversation by reminding ourselves what sine theta is, looking at triangles so that we are aware of the representations. So, for example, that the hypotenuse in this expression here is the longest side of a right angle triangle, like that. We then talked about the degree to which we should consider two triangles, which is 100% for double angle formulas, and we placed them on top of each other in a manner that led to the hypotenuse of the bottom being equal to the adjacent of the top, and that the hypotenuse of the top one had a length of 1. The advantage to this length of 1 is that if I then want to scale up my formulae, I can do it by simply multiplying or placing a coefficient in front of my equations of multiply by 2, multiply by 3, whatever you wish to do, by starting off with a 1 here. And you'll be able to see that later on as you extend your knowledge on double angle formulae. For now, what we need to now consider is this concept of sine. It could be alpha plus beta. I've done beta plus alpha because I was talking at the top going down when I was considering this conversation. So sine beta plus alpha, what does that represent? Well, this means we're going to find a right angle triangle, because again, don't forget this represents a right angle triangle where we care about the relationship between the opposite, the hypotenuse, and an angle. So this beta plus alpha is just one angle. And what angle is it? Well, for this to be the case, it is the angle of beta plus alpha. So it is that there. It is all of this. And then if that is the angle beta plus alpha there, that is the beta plus the alpha, and therefore it's this whole angle in there. Then what is opposite? Well, opposite we can draw by saying, well, let's take the top part of the hypotenuse and draw it down all the way to C, like so. And there is the length O. That is your opposite. So we will make this a slightly bigger one to bring this home. This is the opposite, or that is being represented there. That is the opposite of our angle alpha plus beta, or beta plus alpha. So then what is the hypotenuse? The hypotenuse then is going to be this here. There's your hypotenuse. If we wanted to discuss adjacent, so for example, if it was cos beta plus alpha, then this would be adjacent. And if we wanted to describe the adjacent, it would be from A to C. And so here is our new right angle triangle, which you may be able to see quite comfortably now. We have a new right angle triangle, which is what this is representing. It is representing the relationship between the opposite here, the hypotenuse there, and the angle beta plus alpha here. So there's our right angle triangle in there. And so, again, to go forward, there's other things that we need to consider. So there's the hypotenuse, there's the opposite, and there's alpha plus beta. One other thing that's necessary to consider before we continue is the hidden other triangles in here. So for example, this will be useful later. Bear with me for a second. I want you to recognize that I could put a straight line across here, and then we have another right angle triangle that rears its ugly head. Hi, I am the right angle triangle that's just chilling in that corner. Another thing that might be worth considering is we should label this a letter so that we can describe this little right angle triangle in here. And what manifests when you consider all of these things is this image. Now I'm just going to go over again what it means to have sine beta plus alpha. We are looking at, I'm just going to color it, this right angle triangle in here, where that is the opposite for sine. This is the hypotenuse for sine. This would be the adjacent of the triangle itself. And the alpha plus beta, the double angle, angle 1, angle 2, two angles, the double angle is that. But now we've got some additional geometry to consider. We've got BD, DC, EF, DE, BE, AB, and AE. Now, in these circumstances, what matters most is to consider, for now, what opposite is. Opposite is just BC. So I've just written here, opposite is BC. Additionally, we can say that hypotenuse is AB. That is all I have discussed so far.